Hello everyone. We have seen about the substructure of the bridge, various components of it. Today we will see about bearings, right? Today we will be seeing about bearings, functions of bearings, requirements, and types only. We are not going to explain, going to details of types of bearings, but we'll just understand which are the types. Okay. So first we'll understand what is bearing, right? Device fixed on the abutment and piers to allow free expansion, contraction, and deflection of the beam of the bridge superstructure is known as bridge bearings. So what happens? I have explained what is bearing in the previous lectures. Once again, I will explain you. Right? If this is your abutment, right, and this is your another abutment, this is what is your river valley, and above this you have a superstructure, right? So when vehicles move in this direction, right, it will try to move, it will tend to move the superstructure to move in this direction. If the vehicles move in this direction, it will tend to move the superstructure of the, what are superstructures? It might be slab beam, or it might be T-beam RC structure, it might be arch, it might be the suspension bridges. So any type of bridge which above part depends upon depending type of this bridge, right? So in this case, what is happening? Due to the movements, right, and due to the expansion, due to the heat, right, due to the contraction of the bridge during the cold seasons, right, all this mainly it is due to the movement of the vehicles and also expansion and contractions. Due to the loading, there might be also deflections occurring, right, or not all, and those deflections might not be able to seen, but they are there. As the beam deflects, we have deflections in the beam. Same way, this also acts like a girder. Girder is nothing but a beam, right? So these deflections, expansions, movement of the vehicles tend to move, have a movement over the bridge. It will try to move in one direction or the another direction, right? So to, if we don't allow these movements, okay, if we don't allow these movements, what will happen? The stresses will be developed. Where? Here, at the joints. If there is no bearing, that means there is no, we are not allowing the free movement of this superstructure over the substructure. So we are inducing a stresses in it. So due to the stresses, the lifespan of the bridge or the maintenance cost will increase. There will be cracks, right? And these cracks might be at the start, might be a hairline crack, will start developing into major cracks, right? So for that, what we do, we bring up a structure, right, a structure which will allow the movements, not to the full extent but to the some extent. It will not fully allow and move the superstructure, no, very small movements are allowed so that the stresses are counteracted, right? We allow it freely so the stresses will not develop. If I am trying to pull any object, right, and if it is free to move, then there is no development of stresses, because as I'm pulling it or pushing it, it will move or come towards me because I am pulling it, right? If it is been fixed to the ground and I am trying to push it, right, because it is fixed to the ground and it is not able to move, but I am applying some pressure, due to that stresses will be developed, right? We are resisting it, it is resisting the force which is applying, so there is a stress. So to avoid that stresses in the bridge, we are going to have a structure called bearing, right, which will allow free movement of the vehicles. Due to that, the movement of the superstructure over the substructure, small movements, not large movements, or very small movement, negligible movements, and expansion, contraction, and deflection is allowed. Right. So these structures which allow those three parameters are called as bearings. So you can see here an example, right? This is one of the part. This is a bearing plate. You can say a bearing, right? Here you can see the naming also. The top surface where the or superstructure will rest is called sole plate, right? There is a pin. As it moves, that pin allows to rotate the above portion. The above part or the upper part of the bearing, right? This part will move as the force is applied. If it is moving in this direction, it will move in this direction, tend to move in that direction, right? So there are various assemblies made. This is one of the type to show you what is a bearing, how it looks, right? So it is nothing but a fixed device on the abutments or the piers, allowing free expansion, contraction, and deflection of the bridge. Superstructures are known as bridge bearings. Now, what are its function? What it will do? I have explained all these things, right? To distribute the load received through the ends of the bridge's girders over a larger area, right? To a larger area on the top of the abutments, right? Whatever the load that is coming from the edge of the bridge girders is being transferred over the larger area of the abutments or piers. Next is to take up the vertical movements due to the sinking of supports. What does it mean? Because of the applied pressure above it, it will try to sink. The superstructure will try to sink because the length of the span length is larger. They try to sink below. It is talking about the deflection. Vertical movements is nothing but it is talking about the deflection, right? Transferring the horizontal forces developed due to the application of brakes of the vehicles, right? You apply brakes, the vehicle try to stop and it will try to push the ground surface or the superstructure surface to move in front. Because we are applying brakes, we resist the force, we apply the resisting force, and due to that it try to tend to move forward. The superstructure will try to move forward, right? To provide longitudinal movements due to the temperature changes, right? Along the length of the bridge or the span of the bridge, due to the temperature rise, there is an expansion and contraction of the bridges. So it is talking about that. To avoid angular movements due to the deflections. As you know how the beams act, same thing will happen. Due to the deflection, there are angular movements. We are talking about the bending moment. These are the functions of the what? Transferring the load to the larger area, then taking the vertical deflections, and due to the vertical deflections, they also bear the moments and angular moments. They also bear the longitudinal moments due to the application of brakes and temperature changes, right? These are the functions of bearing capacity or the bearings plate of the bridge. So it should be compact in size and easy to install. It should be compact, it should be small, it should not be very big, and it should be easy to install. It should offer excellent resistance to weathering because it is in contact with the atmosphere. It should be able to withstand the atmospheric difficulties, right? it should be able to distribute the superimposed load uniformly on the substructure and provide greater stability. It should be able to absorb the load that is coming over it and transfer it to the larger area, so that it makes the bridge stable. Right? It makes the bridge stable. Its maintenance cost should be minimum. Its initial cost is very high. This is what is one of the problems in the bearings. It should be able to accommodate maximum expected deck movements and rotations with least resisting force. It should be able to withstand the rotations and movements and longitudinal movements of the bridges. Right? So it is a moving part, right? It moves along the direction of motion, or due to the temperature changes or angular movements, it moves. So what happens is the maintenance of this moving part of the structure becomes very high. It requires a very huge amount of maintenance. It requires a regular maintenance work, checkup. Right? Now types. It is cement pad, cement mortar pad means what? We are going to make a cement mortar and we are going to prepare a pad of it, of a cement mortar, and we are going to place it over the substructure and between this superstructure. Next is the expansion bridge bearings, which are used for the to control the expansion of the bridges. Next is knuckle bridge, roller and rocker bridge bearings. Rubber bearings, where rubber pad is used, like same way cement mortar pad is used. Rubber pad is been placed in between the substructure and the superstructure. This rubber bearing help you to carry out this work. Neoprene bearing pad and sliding bearings, which will slide along the movement of the superstructure, and solo plate on a curved bed plate. A sole plate will be there over a curved plate. So these are the types of bearings. Need not go into deep why it is used, where it is used. Just understand these are the types which might be asked for 5 marks maximum. Right? This was about the bearings, types of bearings, why it is used, where it is used, and what are its requirements, how it should be.